Hello everyone, I'm Dr. Neha Patni. So today we are going to discuss about fuels. Fuel is any compound which on combustion gives you energy, and that energy can be utilized in another work. So basically any exothermic reaction which lend you energy is not because of fuel. But if you are able to extract that energy profitably and you are able to utilize that energy profitably, then only that compound is a fuel. So that compound which on combustion gives you energy and you are able to extract that energy and utilize it further, then that compound is known as fuel. So before selecting any compound or a sample to be used as a fuel, certain analysis need to be done. They may be proximate analysis, it could be ultimate analysis. Today I'll focus more on estimation of nitrogen in ultimate analysis. So we need to find out how much elements are present and in which amount it is. Say for example, how much carbon, hydrogen, nitrogen, oxygen and sulfur present in the sample. So today we are going to discuss how a percentage nitrogen is estimated. Obviously, we are going to use kjeldahl method, which you have learned earlier also. But let's see today how we are going to find out percentage nitrogen in a fuel using this method. Now here if you can see, you're using a kjeldahl flask. So kjeldahl flask, here the substance or the sample which you are to check whether it can be used as a fuel, that you have to take here, and you have to mix it with concentrated H2SO4. So it gets mixed with concentrated H2SO4 and certain catalysts also are required. So in the kjeldahl flask, what we are doing is we are allowing the sample, let's say coal we have taken. So the coal is getting dissolved in H2SO4 and the nitrogen present in coal reacts with that H2SO4 and it forms ammonium sulfate. So basically the nitrogen in the sample is extracted here in terms of ammonium sulfate, but you want to extract it in a pure manner. You want nitrogen extraction to be 100% around. So for that, what you'll do is you'll take that particular kjeldahalized fluid in this round bottom flask, and in this round bottom flask now we are having that kjeldahalized fluid. That means N in terms of ammonium sulfate, and it is reacting with excess of base. So here you have NaOH, which is excess. You have to add it in the excess. So what happens is that ammonium sulfate reacts with that NaOH and it forms Na2SO4, which remains here only. But it also forms H2O and it forms NH3 too. So what happens is that H2O and NH3 being vapor move upwards. And here if you see, you have placed a trap here. Obviously the name suggests trap's role is to trap something. So here what it is going to do is to trap water molecule. So it will allow the water molecule to condense down back and it will allow the ammonia molecule to go further. So what we are doing with the help of trap is to segregate ammonia vapors. So whatever nitrogen was present in the sample in the form of ammonium sulfate you have taken, but with the help of excess of base, that N gets converted into NH3 and you're segregating NH3 with the help of a trap. The water molecule condenses down back and NH3 goes further. Now here, since it is in vapor form, we need to liquidize it. So what we're using here is a condenser, water in, water out takes that heat basically. So what this is acting as a coolant here, and the ammonia liquidize and drop wise it falls in a container, wherein in that flask you already have to keep a known volume of standard acid. Means in this conical flask I have taken H2SO4 and that means I know the normality and the volume. Let's say you have taken one normal H2SO4 and that too maybe 10 ml. Okay, so 10 ml of one normal H2SO4 you have taken. Now how are you going to find out that how much amount of nitrogen is present in it? So for that what we'll do is we'll titrate it with a base. Now when you are going to do that, what happens is I'll show you how. So this is nothing but the reaction only which is written, and I have explained it properly. Now let's see the overall reaction. What is happening here is you have taken coal sample and in coal you had nitrogen. So when you have added H2SO4 to it in the kjeldahl flask, the nitrogen has reacted with it and it forms ammonium sulfate. And to purify and extracted properly, you have taken it in round bottom flask, heated with excess of base NaOH. So what happens here, you may see simply that NaOH reacts with it and it converts it into NH3. Ammonia vapors further react with H2SO4 and it gets absorbed. Now what you have to do is to titrate this particular acid with base. So what we'll do is we'll keep a base here, and in the acid we'll titrate that 10 ml of H2SO4. Now obviously this base is going to neutralize the acid. Which acid? Which is left after absorbing NH3. You have taken excess of H2SO4, you have taken 10 ml, right? Now let's say that out of some 10 ml, some of the amount of H2SO4 is utilized in absorbing and is converted into this, but some is left. Now how much is left? That you have to know by titrating it with base. Now let's say this NaOH, you are using, let's say NaOH, one normal NaOH, and whenever the color changes using maybe phenolphthalein, you'll know the end point. Now let's say the end point here is 2 ml. That means 2 ml of NaOH is utilized in neutralizing this solution. Which solution? Out of 10 ml, 2 ml is getting neutralized. That means 8 ml. 10 minus 2 gives you 8. That means 8 ml of the H2SO4 was utilized in absorbing NH3. So from this volume, we'll be able to know how much H2SO4 is consumed in absorption of NH3, and we assume that whatever is the amount used up, that is the amount of NH3 formed. So basically around 8 ml of the NH3 formed. Now to do the calculations, we'll simply assume that the weight of coal is W gram here. Volume of acid used up. So this V1 is nothing but what is used up? 8 ml. And how did you get that? 10 minus 2 means the total amount of H2SO4 minus leftover amount of H2SO4, which you get after titration. So this is the amount of H2SO4 which is used up, and the normality is N1. So now we assume that whatever acid is used up, that means that much amount of NH3 is formed. Now obviously in 1 normal of NH3 solution, you have to dissolve 14 grams of nitrogen in 1000 ml. So if it is 1 normal, 14 parts are getting dissolved in 1000. So for N1 normal, how much it would be? And 14 parts get dissolved in 1000. So how much part will get dissolved in V1 ml? So using that funda only, that 1000 ml contains 14 parts of nitrogen. So V1 ml of NH3 contains how much part of nitrogen? So 14 by 1000 into V1. Now 1 normal, you have 14 parts of nitrogen. So in N1 normal, how much parts of nitrogen are present? It's that simple. If it is 1 normal, you will say. If it is 2, you'll multiply it with 2. If it is 3, you'll multiply it with 3. So this N1 factor is extra because you need to convert it into the normality thing. So 14 by 1000 into N1 into V1, that gives you the amount of nitrogen present in that much NH3. Now this is the amount of nitrogen. What you want is the percentage of nitrogen. And for that, you have to divide it by sample weight. Multiply it with 100. So when you divide it by sample weight, which is W, here it is written, and when you multiply it with 100, you will get this 1.4 N1 V1 by W. Again to remind you, N1 is normality of the acid and V1 is the amount of acid used up, and W is the amount of coal taken. Now if you have understood how to find out percentage nitrogen, let us cross check using this numerical. Here you can see that you have taken 1 gram of the coal sample and NH3 gas thus evolved was absorbed in 5 ml of 0.01 normal H2SO4. That means the H2SO4 taken is only 5 ml. Now after absorption, the excess acid required 2.25 ml of 0.01 normal NaOH for exact neutralization. That means you have taken 5 ml H2SO4, you have let that ammonia absorbed in it, and then you titrated it with a base. And the base reading is 2.25. That means the leftover thing is 2.25. So how much is used up? Used up is obviously 5 minus 2.25. Now if I ask you to find out the nitrogen for that sample, what you will do is written here. 1.4 into N1. N1 is normality, which is given 0.01. And then V1. What is the amount used up? 5 minus this. Multiply by V1, that is 5 minus 2.25. Divide by W, sample weight, which is here 1 gram. So overall, if you calculate this, you will get the percentage nitrogen to be around 0.039. So simply by using this formula, you can easily calculate the percentage nitrogen present in a sample. Now, how to find is done. Why to find that percentage? Though nitrogen has no place in Dulong's formula, and that means it does not directly contributes to calorific value. So its place is totally undesirable. We don't need nitrogen to be there in the fuel for the sake of calorific value. But if it is present, it is helpful in making other byproducts out of it, like ammonia, pyridine, etc. are very much used. So for that, sometimes we need to know how much nitrogen is present. And that's all for now. So I think you will be able to understand that zeolite method today. Thank you.